Hello and welcome to the future once again. This is our third and final episode of the new world being created in the playground inside Silicon Valley in California. In this program, we look at some of the actual products that are being created. Some are top secret, of course, some soon to be launched. Each one has something really special and mind-blowing. But first, let's do a quick recap from our earlier episodes, starting with a founder everyone calls the magician, Peter Barrett. The kind of areas that you're working on, the borderline of improbability and impossibility, what are those?
Well, so we're looking at things like next generation computing, things like robotics, things like the replacement for classical computing and the advent of quantum computers, which will be revolutionary.
Quantum computing, give me an example of what you're trying to achieve with quantum computing.
With a quantum machine, an engineer can create fertilizer at room temperature the way that biology does. We don't know how
replicate biology, which is one of the most complex natural forms of transformation, right?
And we'll also be able to engineer catalysts and materials that go well beyond what nature does, right? We don't understand how photosynthesis works. We don't understand the mechanism of at the core of photosynthesis. And we could design a process which does the same thing, which is enormously more efficient. We could have buildings that literally sublime out of thin air. Trees do it. Trees are made of air, right? There's no reason why we can't grow buildings the way nature grows trees.
Grow a building.
So, there is carbon in the air. There's all the materials in the air required to build a building. You can imagine with the right catalysts and the right material science, having a nanotube building grow out of literally thin air.
Wow, that is mind-blowing. And you also mentioned you're working on optical computing. What do you mean by that?
That's correct. So there's one of the limitations of computing today is to move electrons around inside silicon takes enormous amount of power and generates enormous amount of heat. Photons are much easier to move around. They're potentially much, much lower power, and you could do computation at a huge scale, which physically isn't possible with electrons and silicon. So we have a company that's building a neural network accelerator which is entirely doing the heavy lifting in optics and can be many, many, many times faster than its electronic equivalent. I've heard one of the CEOs here say that he believes that the computing revolution hasn't happened yet. I believe that. I also believe the industrial revolution hasn't really happened yet either.
So that was Peter Barrett, in charge of technology at the playground. No wonder they call him a magician. Before we get into looking at some actual products, let's see how many of them came into being with the help of robotics and artificial intelligence. The key founder at Playground, Bruce Lee, gave us a glimpse of the future. I find this probably the most inspiring place I've been to anywhere. And that's saying maybe not much, but I love it. And it's your brainchild along with the team. God bless you. And what made you think of it, and what's the objective behind it?
Well, I think I really appreciate the compliments. When the four of us got together to found Playground, it was really about thinking about how could we give back to the next generation of entrepreneurs. The four of us have been through more than a dozen startups over the last 30 years, and we've really had a great experience. And we want to make sure that the next generation kind of has all the tools and the capabilities to not make the same mistakes we've made when we were young.
Right.
And that we can participate in their journeys and enjoy the ride.
And then learn from them as well.
That they're all going on. And hopefully we can all make new mistakes. And
but
so
you've got to pivot all the time. For youngsters who are watching this, there will be occasions where you will have to change course, there will be setbacks, etc. Right?
Things never go as you expect. And that's why, fundamentally we invest in great people. Who want to go change the world, and how they actually affect that change, no one's exactly sure. They've got an idea today, and they're going to follow that idea as far as it can go, and maybe bounce off that wall and correct into another direction. We just want to make sure that at the playground here we have everything they need to make them as successful as possible. And so, we think of ourselves as a startup. And so we need to do things differently. We need to be able to move faster. We need to be able to, be more creative. And we need to learn from our own mistakes.
Exactly.
And so at the playground, we want to make sure we have everything a startup needs. So beyond just, money, we want to make sure they have a great environment. We want to make sure they have all the tools they need, technical support.
You give them a huge amount of technical support as well. You have a team that really guides all these youngsters, right?
Well, I think having, mentors and having, seasoned technical professionals help them, once again, not make mistakes that have been made before and points them in the right direction so that they can focus on the core differentiation for their business.
But what do we have this young...
This is one of our prototypes.
No wonder you call it a playground. This is what you do for your life. I want your life.
We play hard.
So this is an electric conversion of a go-kart, and right now we have an operator. It's incredibly powerful, which is probably a mistake for having it inside. But actually, it does have a purpose, which is every year we have summer interns come to the playground. And last year they created a robot that would go make coffee and bring it to your desk. And this year,
wow, that's amazing.
This year the plan is to have the summer interns make these go-karts drive autonomously. The whole idea for a startup is to save time and money.
Exactly.
Right? And so that if they can, get through the process quicker, they can get to market before their competitors, and they can spend less money, which makes them more efficient. And then this is one of our other exciting tools. It came a little later in Playground's history, which is called a 5-axis mill.
5-axis.
And so it can change the thing that holds the stock product. So here it is, it's spinning it, as well as it can move the cutting tool in 3 dimensions. So the cutting tool moves in 3 dimensions. The holder moves in 2 other dimensions.
Wow.
And that allows it to make a 5-axis cut.
The precision of it is so impressive.
This one is a real robot, right? It can do anything. This is used in aerospace to make rotor blades for a turbofan.
Okay.
Or a jet engine.
Where you need precision.
And so we have portfolio companies here, of course. And we have our electronics lab, which we get to, we get the privilege of having, some of the electronics equipment that most startups would just dream of. We just have it available because across dozens of startups, it makes perfect sense just to have it here. Saves time, saves money.
Wow. And everybody, all the
companies
everybody
get
gets to use it. Lovely, lovely. Amazing stuff. You can see all 3 of these episodes of The Playground on ndtv.com. Just log in and search for Playground. Now let's take a look at some of the actual products coming out of the Playground, as we talk to entrepreneurs and the brains behind the desire to change this world. Now, the world of self-driving cars and autonomous vehicles is a major, major focus all across the valley. We caught up with one entrepreneur, Stefan Heck, who has already produced and put in operation a clever 2-way camera that will also be an important input into traffic safety and self-driving cars. Stefan, thanks very much for joining us.
Great to meet you.
You are slightly busy generally because you're creating this great startup. Just describe to us exactly what it's about, because I've heard a lot about it and it's the buzz around here. What's it all about?
Well, we're building an intelligent data platform for safety data, both for human driving as well as for future autonomous driving.
For safety. Right?
For safety, that's right.
And how, just a few more details, what does it involve and how do you achieve that goal and how successful have you been?
So on the human driving side, we retrofit artificial intelligence and sensors into commercial vehicles. So these are truck drivers, taxi drivers, ride-sharing drivers, delivery vehicles. And it sits on their windshield. We look at the road and we look at the driver behavior. And
so it's a kind of camera?
It's a kind of camera, yeah.
Okay, you got it.
It looks like this, mounts to your windshield.
Okay, so it sticks like that to the windshield.
Yeah.
And
this looks at the driver, so it peeks over your rear view mirror, if this is your mirror. And then the outside looks at the road ahead of you.
That camera looks at the road ahead of you.
Right.
So you're constantly looking both inside and outside.
Right. Okay. And the computer vision is watching. to see is there a risky situation emerging, the lights turned red or a car has cut you off.
Right.
And then on the inside we're looking, is the driver paying attention? So are
Right.
they looking then at their mobile phone or maybe talking to a passenger
Right.
or daydreaming out the side of the
Yeah,
vehicle?
yeah, okay.
And then we look at combinations like that. And if it's a serious situation, we give the driver an alert.
Like a verbal alert?
Either a tone or voice, depending
Okay,
on how
right,
serious the
right,
situation
right,
is. And we also give feedback at the end of your trip. So you can see, we calculate a
Okay.
driver score.
Oh.
That goes from 0 if you're very risky to 100 if you're perfect. I'm definitely not perfect.
None of us are. And that's the speaker.
That's
kind
the
of thing.
speaker, that's right.
Okay, wow.
That's right, yeah.
And how successful has it been? How important is being distracted in terms of accidents?
So distraction is literally the top cause of accidents today.
Really?
We talk about them as collisions because
Yes.
they're usually predictable, actually. You
Right.
can see the patterns that lead to them.
Right.
And if you look at collisions on the road today, first of all, they're not evenly distributed. You have 15% of drivers that cause most collisions, 85%.
Okay.
And at the other end of the spectrum, you have about 20% of the population that will go their whole life without causing a collision. They may still get rear-ended by somebody or
Yeah.
be in a collision,
not
but it won't be
their-
their fault.
Right.
Right.
So
we look
20% are very careful and 15% are, what do you call them?
Reckless.
Reckless.
either that or what you see is early when you first learn to drive, you
Yes.
tend to be worse.
Okay.
And people who are getting into senior citizen years, 70, 85 years old, they also start to, with perception weakens, reaction time lengthens, they tend to get worse as well. But there is just individual variation.
Okay.
So we're out to learn from the best drivers, that 20% that never causes collisions, because there's a lot to be learned about how humans behave. We make way for bicyclists, we make way for animals, we take more space if we see a driver is having trouble.
Right.
All of those behaviors are really important for future autonomous cars. They have to fit into the human traffic flow.
Wow.
And then from the bad drivers, we learn about all the risk scenarios, and of course an autonomous
Huge
car.
learning from this.
That's right.
Real-time learning and in real situations.
That's right.
Yeah.
So it's the whole system is designed to be a gigantic learning system. We give the driver feedback so they know the abstract learned data is pooled, but it's completely without any personal information.
Anonymous.
Anonymous, so your privacy is protected. And there we learn how do people behave at red lights, in four-way intersections, on freeways.
Wow.
And that's what we use on the other part of our business, working with automakers to build future safe autonomous cars. So they build the cars, we provide the intelligence, the software.
So
for
all
the
this
safety.
data you're collecting is anonymous, but to the fleet owner where they can see which particular driver is better and
Yes,
worse.
they can see their own drivers,
Right.
but the aggregated data across all fleets, that's anonymous.
And about a year ago, you raised a little bit of money. Like,
Yes.
I can't remember the amount. It's
We raised about $160 million.
oh, gosh, only 160 million. Well done. That's
Thank you.
obviously that's
Thank you.
brilliant. And that was a year ago.
It was a year ago, yeah,
Wow.
from SoftBank, Masayoshi
Yes,
Son,
yes.
and Greylock, Reid Hoffman, who
Oh, yes.
founded LinkedIn.
Yeah.
So.
Now, the other aspect is that it also records incidents. So
Yes.
if the driver feels that there's about to be an accident or there was an accident, and I do want to show that it's not my fault, or I do
Correct.
want it recorded on,
Yes.
can be done?
Yes, can be done. So we have a small button that the driver has control over. They mount in the vehicle, and
Wow.
when they click the button, it will upload data. We see a lot of unusual events. Sometimes it's a threat by a passenger if you're driving a taxi. So we protect the driver from somebody who may be drunk or whatever other reason. Or just an unusual event, somebody cutting them off, a danger.
So both inside and outside you can.
Both inside and outside in that case, yeah. And even in the regular events, in most commercial vehicles, it's rarely actually the commercial driver's fault. It's usually the other person in the traffic. And so we protect the commercial drivers from false accusations of liability when it really wasn't their fault.
So what I've learned here is that everybody starts off with a plan, and then there are always things don't go exactly as you have to what they call pivot.
Yes.
Right. So what did you find were difficulties, and how did you pivot and get over them?
Yeah. Well, we started actually with mobile phones.
Oh.
And we found that mobile phones would overheat if you drive for extended periods of time. So for a short commute, 20 minutes, mobile phone is perfectly fine. But if you're a professional driver and you're driving
Fleet,
8,
yeah.
12 hours a day, you need a dedicated device. So that was our first pivot.
Okay.
Second one is we originally planned to be just in the US and then go to Europe. We actually found that Japan is very excited about dash cameras and about safety.
Okay.
So we made Japan our second geography,
Okay.
and we'll grow from there. And then we found that a lot of people who already had telematics devices want to upgrade into visual telematics to be able to have
Right.
computer vision as well and see the safety scenarios. So originally we thought that some of those telematics companies might be competitors, but actually they've turned into great partners
Wow.
where we're deploying together. And they're tracking fuel, engine performance, and we're tracking the safety situation.
So you went from here to Japan. When's India coming on your
Eventually.
radar?
Eventually.
On your, when you go
Yes. We would love to do India one day.
You will.
We're not ready yet. India takes more work.
Generally true. Well, that's wonderful, and it's just a great idea, and many, many congratulations. And you've had a very strong tech background, right? That's why you did this. What did you do at college?
Yes, I did a PhD in philosophy. A
Perfect.
very deep tech background.
Wonderful,
Great to meet you.
inspiring.
Thank
you
you.
very much.
So that was Stefan Heck, from a garage startup to a successful product and enterprise, thanks to support by the Playground. Before we move on to some other major innovations and products, we talked to one of the youngest decision makers in the Playground, Jory Bell, who explained how they review, understand and select new projects.
You know, this is just a dream place for youngsters like you. So what is somebody who wants to get in here, what are you looking at and what kind of investments do you make?
Well, I mean, first we're investing in people. So
Right.
founders who have a big vision and who we think can take that vision, the long haul that it's going to take to make a successful company.
And all the mistakes and ups and downs.
Yeah, it's all. I mean, whatever the plan is that they come in with, there's going to be challenges they haven't foreseen, and do
Always,
they
though,
have,
is it?
Oh, always, like
Okay.
instantaneously. The startup world is constantly changing. Like many companies pivot from their initial idea to something hopefully better or maybe just different. So I think so. First, the people is
So
the critical
first,
part.
I love that. The first is you look at the people involved.
Yes.
Okay.
Yeah. And then
And sorry, just
Oh, no, yeah.
you look for passion and an idea.
you look for passion, you look for honesty, you look for how they interact with their team and the people around them. I mean, a founder is going to spend most of their time raising money and hiring people as they grow,
Right,
and then holding the vision of the company so that everyone else is working in the right direction.
Okay.
And so,
So,
I mean,
okay,
a lot.
that's what you look for.
Yeah.
Right.
And then
Leadership, passion, idea, everything. Okay,
Yeah.
that's in one. Then what else?
And then frequently, well, always, we're looking for a really big vision, which usually also means solving a big problem. And
Okay.
that's kind of has two parts to it, I think. One part is that those are where the big financial opportunities are, but also that's where the big changes can be made in society and for future generations. And so we're shepherding a lot of resources and kind of placing bets on technologies and companies, and no one technology is inevitable. And so it's kind of both a privilege and a responsibility to kind of help decide kind of what are the directions that we think technology should be moving and to put resources in those directions.
So you're looking at ideas or projects that have some social impact. Is that what you're saying? That change, you said, make major changes in the world.
Yeah, well, and most of the big businesses will make major changes in the world, right? You look at Facebook, you look at Uber, you look at Google, you look at Apple, right?
Changing our lives.
Yeah.
Yeah.
So if it's a big business opportunity, it's going to make a big change, and so we have the opportunity to help affect that change, and so we're looking for kind of those big ideas and the entrepreneurs who are going to be able to realize them.
Right. Give us some examples of the kind of investments you are making that will have, or some that have already fructified.
So we're a little over 3 years old. So
right. So you're
the
just
life
beginning.
cycle of a venture investment fund is around 10 years, typically 10 or 12
okay.
years,
Right.
which is good because it's taking longer for companies to exit. There's a lot more money available right now, so companies that used to go public quite early now can continue to raise private money, whether it's from huge funds like the SoftBank Vision Fund or just venture capital writing bigger checks and private equity. So people
Oh,
are
I see.
staying private longer.
Oh, that's very interesting. That's very interesting that capital is not as short a supply as it used to be.
Oh
Is that
no,
right?
yeah,
Okay.
definitely not. Yeah,
Wow.
I mean, it by stage it varies over time,
Yes, yes,
but
yes.
yeah.
So would you say there's a kind of reversal between capital and talent? The talent is in short supply now?
So definitely. That's an interesting question. I feel like we see so much talent come through here that it's hard for me to feel like talent is in short supply.
No.
Right? I think the combination of the right talent, the right ideas, putting that all together,
Yeah.
and I think especially in certain areas of the country like Silicon Valley, and one of the things that made me come here is that you have that concentration of ideas and people and capital, and it's just I think there are those concentrations that make a big difference, and that happens in a lot of industries. Like if you're in the movie industry, that happens in Los Angeles. If you're in the banking
Yes,
industry in New York or London, and
Right,
I think
right.
for the technology industry, this is one of the areas where you have everything in one place. So you don't feel about a big lack. There's a little bit of a sense of competition for talent, which is interesting for
yes.
startups because companies like Google, Facebook, and Apple are paying such huge amounts of money,
Quite
and-
rightly.
yeah, for talent, and like key disciplines like machine learning scientists or people studying AI can just make incredible sums of money working for these large companies. And so, how do you convince them? I mean, the bar is much higher for a big idea because they have to be really convinced that this is going to be the next Google or the next Facebook
yeah.
to be a part of it and give up $1 million salary at at one of these large companies.
So give me some examples where you're actually investing right now. I mean, give us some projects and...
I think we're doing a lot of investing in new computer platforms, automation and robotics, and artificial intelligence, and also next generation manufacturing. And usually the companies that we find interesting have an intersection of more than one of those categories. So for example, we recently invested in a company called Relativity Space. That was some young engineers that came out of SpaceX and Jeff Bezos' Blue Origin and started a new rocket company. But it's not just another rocket company. They're also applying 3D metal printing technologies to be able to print the entire rocket in order to be able to increase the pace of production, increase the quality,
Safety.
and kind of, yeah, sorry.
Wow. I mean, make them safer. So people are invested in something that's going to use 3D printing to print a rocket?
So everyone right now is using 3D printing to print major components of the rocket, the engines and a lot of components. And we actually also have an investment in a company that just makes those printers for the highest end aerospace and medical printing of metal, of titanium and stainless steel. And this company is using those for the small parts and then using huge industrial robots with laser welding to make structures that are the full scale rocket, like the whole tank structure, everything that you see printed just with these huge robot arms. So.
Fantastic. I'd love to. I think we have a short video of that. We're going to have a
great.
look at
Yeah,
that.
no, it's really something to see.
Mind-blowing. Is it called Casey, a two-legged robot?
Cassie, oh yes, Cassie is agility robotics. So that's actually so our founders and Andy especially has a lot of experience in the robotics industry, and so we, especially with legged robots. So everyone's seen the Boston Dynamics robots, and we have here a couple of like Shaft is a Japanese robot company that was one of the first companies making kind of amazing walking robots. But
Those are the feet, are they?
Yeah, those are the feet there. It's kind of hanging right now.
Yeah.
And all of these, they're amazing, but they are very energy intensive. And so some folks at a university up in Oregon developed an extremely energy efficient way, kind of mimicking how animals and birds and people use passive dynamics to store energy when they don't need it and then to use it when they need to go. So instead of operating for 15 minutes on a battery, the walking robots that they're developing can go for hours at a time. And part of what's exciting about walking robots is that so much of the world is already built out for humans. Like right over there behind us, there's a stairway, and if you need to do last mile delivery, if you need to deliver something to an old person who is living up on a second story walk up, then that's not going to be a rolling robot or a drone. That's going to have legs like humans because the environment's built for humans.
Yeah, most of it, until that changes, you really need for many decades human-like robots.
Yeah.
Wow, wow.
And actually, I think hopefully the environment will continue to be built for humans and not be built for robots. So I think the robots should adapt to the human environment. We shouldn't have to adapt our environment to the robots.
Quite right.
So
you take an idea, you're impressed by the team, the founder, and you take it right to market. You take it to raising funds, or
so we do a couple of things.
You keep training them. You have about 50 people here to train them, I believe.
So we do a few different things. We invest money directly. We have our 50-person team, which is full stack engineering, and all the folks we work with, they're super skilled. They have worked at large companies, they've worked at small companies. All of them have worked at both. So they both understand that you need to be flexible, and there's lots of challenges and resource constraints when you're a startup, but you also need to put the foundation of the right process and the right discipline, because when you're a big company, all of that is really important, because it's not just a few guys in a garage anymore. Right. And so our team can help them through that path. And so many transitions when you're in a startup that you don't expect. Like, it's very different. Two founders to a dozen people to 50 people to 100 people to 1,000. Each of those transitions is just very, very different set of challenges. The expectations will change, frequently just going up in various areas. And the kind of founders that we want are people who we think are going to take that company all the way. They may not. They may have the self-awareness at some point to say, well, actually, I'm really good at up to 1,000 people, and now you should get someone who has experience taking a company public. But we usually really want to believe and do believe that that person has that capability. They're an athlete in that way, that they could take it the whole way.
Wow. So is it a sprint or a marathon?
Well, it's both. It's both.
Sprinting the same distance.
So you can't sprint the whole time, right? So
who's he when he's at home?
Well, who's he? This is actually this is Andy's. It was a Kyoto artist who makes robot sculptures out of trash.
Oh, wow.
And so,
fantastic. Yeah. And this is more from my generation.
Yeah, the Hubert is good.
Okay, so that's absolutely amazing. You like to see the same people all the way. They should have the capability, but if they don't, it's their life choice.
Yeah. So I think that it's definitely a marathon, and one of the keys is to understand when is it worthwhile to sprint. If you have a critical deadline to get something for, a lot of times it's a very simple deadline, a trade show, a fundraising activity, a customer who needs something by a certain date. And so that, then it turns into a sprint, and everyone understands that and works together and maybe pulls all-nighters. But most of the time, it's just about a consistent hard work over a number of years. I mean, it is the exception to have a company that, it's just a year or two and suddenly, a huge thing. And a lot of times it's, 5 years, 10 years, even more that a company can be.
Tell me something about how the playground would be relevant to a developing country like India. The kind of technologies you work. I heard just about from Peter about agriculture. If you're getting great food at a lower price, it could eliminate hunger to some extent, to a large extent.
Yes. So food is definitely one in an area that I'm very interested in.
Okay.
So currently we're looking at a lot of indoor farming and vertical farming, where you move the farming close to cities and eliminate both the large land requirements and
Okay.
also the transportation requirements.
Wow, wow.
So that's one that interesting. I mean, I'm sure our new compute platforms, like our optical computing company and our quantum computing company, can be used to make new drugs
For healthcare.
for healthcare and to make safer pesticides for agriculture, to make new materials that have strength or other attributes.
These
that-
are very relevant for us because we have the worst pesticides, the most dangerous, cancerous. And I guess another area is that you value engineers a lot. India produces the most engineers, more than the United States does. So there'll be a demand for engineers.
Oh, definitely.
Yeah.
Yeah. I mean, and if you look at a lot of our most cutting edge companies, the majority of the engineers may have come from right now or originally from another company, because the United States is a nation of immigrants. and
Another
that's-
company, another country.
Another country. I'm
Okay,
sorry,
okay,
another
yeah,
country.
sure.
So, and we're seeing there's been an acceleration, I think, in companies being founded by PhDs in the hard sciences.
Okay.
Right? So
right,
where it
right.
used to be, it was more just computer science or electrical engineering. Now there's an emergence in biotech. So people who may have a biology or a genetics PhD are starting a company. Folks with material science PhDs starting companies. So I think there's been an acceleration where it used to be, like I had the perception when I was young that that getting a PhD was mostly about being an academic, and then it was sort of like, well, maybe you're a high-end person in a big company, and now a PhD is maybe one of the more likely paths to become an entrepreneur.
Wow.
Right, where that used to be not as much of a connection or a requirement, and in every hard science too.
So I did well getting a PhD. then.
Yes, definitely.
Many years later, it makes sense. A lot of people say you're just a Bengali academic. You wanted those letters, but now it's practical. You can
It
really
is,
use
it is.
So a lot of PhDs out there should be happy.
Yes. Yeah, more and more founding PhDs we see. They're not just the CTOs, but they're the CEOs as well.
Wow, that's fascinating. God bless you for the work you're doing, and thank you for changing the world, and good luck.
Thank you
very
so
much,
much.
Jory.
Thank you.
So that's Jory Bell. They look for big ideas at the playground. Now let's do a quick run through some actual projects and products. My friend Ajay Madhok, a brilliant techie entrepreneur himself, met a host of youngsters and asked each one of them how they intend to change the world.
We're trying to build revolutionary phone products that use quality materials, minimalistic software to give consumers the opportunity to really make the phone experience their own. And that's exactly what we've been doing here with this first device here, which is our PH1. What you're looking at is I'll kind of walk you through a little bit of the materials and the premium quality here. So we use ceramic on the back, titanium on the sides, edge-to-edge display, as you can see here from the menu screen, and we're the first company, the first real true Android company to do this. So, and this phone is designed to be really extremely durable, not one you need a case for, something that you can take as your own, premium quality hardware, minimalistic software to make really your own product. And that's really how we want to differentiate, is we're not going to give you a bunch of bloatware, we're not going to require you to go down a certain path. It's yours to do with what you want. So really, that's why it's PH1, it's your phone.
We enabling robots to manipulate everyday objects. We basically building the brain behind the robot that can grasp things. So what you see in the background is the robot that is basically on a task. It picks items from one set bin and places them in a different bin. The robots are very much in the early phase and learning. In fact, in the background, you see the robot picking things and putting them, right? So it is doing it in a very fast rate, very reliable, and range, rate, reliability. That's how we evaluate them. It will take them time to pick a coffee cup and actually do something with it, but it's already ready to work in a warehouse.
Changing the world by creating risk scores that predict the onset of cardiovascular disease much earlier than you can do with any technology out there. So we built sensors that can actually measure the electrical signal of the heart. So if you're familiar with an ECG, putting electrodes across the chest to get that electrical signature of the heart, we can do that actually through your feet. We're the only device that can do that. Then we can also measure the mechanical function of your heart. So typically if you'd go into a clinic and get an echocardiograph, have imaging done of your heart, we can pick up a lot of those same parameters, but through your feet once again. So we make it really a daily ritual.
This company started about, I would say, 30 years ago. As a 7-year-old child, I was in a hospital with septicemia, which is severe blood infection. And when they were discussing my mortality, my fleeting thoughts were all focused on play and the protection and the innocence of play. That desire to constantly want to immerse myself in creativity and movement led me to become the head of design for Jordan Brand at Nike. So for 14 years, I worked with some of the world's most accessible heroes, which are athletes, designing products that help them perform, help them dream, help them execute against their goals. Then I realized after my own son had gotten sick that we do not invest in the protection and the well-being of children enough, specifically around play. So I resigned, started to research. I went back to Stanford where I have my master's in business, and I jumped into the design school to understand the trends of children going from subscribing to the archetype of an athlete to the archetype of a superhero. And what was beneficial to this model is anyone can become a superhero. It's just about imagination and creativity. So our first product experience is called the Tumbler V1. It's built for how children move and how children play, but thematically it's allowing them to see themselves as the hero. And as we grow, we'll build out an ecosystem of products and services and experiences that allow the child to really display their heroism on the playground, in the classroom, and beyond. So the product actually has a really unique design feature to it where it's a two-handed experience. When they hold it, they have to really become intimate with the product in a way that builds trust. And so children typically hold what they love. The removal of the product is symbolic of removing the sword from the stone. And so it helps them transform from their regular self to the exemplar self. When you open it, there's a sound that plays that says super heroic. So that's the signal that you are now stepping into your own character, your own hero. They get the footwear, there's a bag that converts to a cape, and so they're able to physiologically transform into this character that they have in their mind. This is all backed by research. There was a study that was done at the National Health Institute called the Batman effect. Children in character tend to perform and hold themselves to the ethics of that character. So when you think about a superhero, children know they're here to help, they're here to save, they're here to be a relief from the world's trouble. They believe that they actually can be problem solvers. So it's a fundamental right that children should dream, and what we're trying to do is protect that.
We're bringing automotive level autonomy to industrial applications like warehouses and factories, moving materials much more efficiently. So it's a 3D vision system that maps the world, sees the world in full 3D, and because of that can make very intelligent and safe choices about where to go and how to interact with people. The Canvas cart is being used in a wide variety of applications. Today it's being used in manufacturing companies, helping to move material more efficiently from work cell to work cell, or in e-commerce situations or warehousing where they're trying to get material out faster. This is the first example of camera-based autonomy. So there are other systems out there that work in very structured environments with 2D LiDAR, but there has never been a system out there that's using cameras to guide its autonomy. And what that does is gives much more information in order to make intelligent decisions and work well with people. There's a simple drag and drop interface. The cart will make its own map, and then there's a simple drag and drop interface to tell the cart where exactly you want it to stop and what you want it to do.
So up until this point in neuroscience, there's been a prevailing theory that maybe individual neurons correlate to certain types of behavior. What our microscope does is offer a larger field of view and the ability for the mouse or the rat or the animal of your choice to freely behave. And so what that means is that you can correlate behavior with the neural activity that our microscopes are imaging. And these are called neural circuits. We believe that neural circuits are a better proxy to figure out what they're actually doing. We offer 2 different microscopes. One is just purely calcium imaging, so imaging neural activity. The other one is Invoke. It is an optogenetic microscope, and what that does is it gives you the ability to excite or inhibit different neural circuits, so you can study the effect of inhibiting, say, the reward center or exciting the reward center of a mouse, or exciting or inhibiting the place cells that cause mice to move in certain directions. So ultimately, we want to understand the brain, we want to heal brain diseases, and we want to figure out what's actually going on in what's controlling all of us. So right now we are not doing anything on humans, but in the pharma industry, we use mouse models for different brain diseases. So there are different mouse models for mental illness, there are mouse models for Parkinson's, there are mouse models for Alzheimer's disease. And so over the course of these longitudinal studies, what they really want to do is find out what is changing in the neural circuit behavior. You know, as the mouse loses motor function or as the mouse is having a seizure, what's actually going on in the neural circuits of the brain that causes those things. And hopefully with drug treatment, we'd be able to either stop, slow down, or maybe cure that disease, at least in mice.
Well, we are adding a new dimension to media. So today when you think of media, you have sight and sound. And when you look at like your phone, you'll see there's already a retina display. It's as good as you can see, basically. So people have tried adding things like 3D, but you essentially have the vision about as good as it can be. When you listen to a CD even, which has come out many years ago, the audio is about as good as it's going to get. I mean, they're doing things with 3D audio and this kind of thing, but what we're doing is something completely new. We're adding a new dimension to media, which is feeling. So actually being able to feel music, feel what's going on around you.
Come on, let me see your hands in the air when you hear this, when you jump off on your chair. Get your freak on, run like you don't care, and bust it go down, show them you're prepared. It's like cross it, dancing and you know footwear. Let them know you are the best dance around here. Step up on the dance floor when the rocket disappear. It's about to go off just like a nuclear.
Things like augmented reality or virtual reality, it makes it more like you're there. But in other cases, like just listening to music, it adds a new dimension of how you feel it. It's like you're at a giant concert and you can feel the bass, you can feel the drum. We add that experience to any kind of media. So it really depends if it's a movie, if it's a virtual reality experience, or if it's just listening to music. It applies a little bit differently. It can actually work with existing music where we do audio processing to understand certain things about the music. So what's going on with the percussion, what's going on with the bass, and what's going on with the rhythm. Think of it sort of like dancing. And then we encode that based on your preferences and based on the environment, ideally for that scenario. Then there's basically material and transducer that are in the product that will vibrate to create the optimal experience to reproduce the environment that the artist had in mind when they created it. Things in automotive, for example, you're not allowed to drive with headphones on, yet deaf people are allowed to drive. So we think there's some very interesting things we can do there to make the environment augmented and much richer for people who can hear as well as people who are hearing impaired.
Yeah, we're out here today at the Playground pop-up with Skydio today. It is the first fully autonomous camera. So it's a camera that flies itself to get awesome footage of you. It's great for everything from sports videography where you're trying to capture something while being hands-free, or if you're trying to fly something where a typical drone can't fly because if there's too many obstacles in the way, Skydio is able to see the world around it, avoid obstacles to keep its subject in frame. So there's cameras on Skydio, which helps map the world around it, and it puts it all through the NVIDIA TX1, which is the same brain that you'd find in like self-driving cars. And it's doing all of this on the fly to map the world around it and get the best footage possible. There's many people doing drones, but we really have a different paradigm shift on drones from other people. Where other drone manufacturers have a manual experience at their core, we've really built up from a fully autonomous experience from the ground up. So it allows you to put the drone in the air, put your phone in your pocket, and focus on what you're doing instead of having to focus on flying the drone. And with that, it allows you have almost no learning curve whatsoever. So if you know how to use the camera app on your phone, you can fly Skydio R1. So I think that autonomy opens up so many different use cases that before were just like unable to be done. When you think about like drones as this larger thing, autonomy is kind of like what people think about, one that can capture amazing things for them. They don't think about like having to become a professional pilot. So autonomy opens up just so many use cases that were forever like held to just those that knew how to fly before.
Fin is a smart water sensor that manages your water chemistry 24/7. It's tied into a fantastic system on your smartphone, so we can actually analyze your water chemistry 24/7, tell you what's going on, and to give recommendations and dosing for looking after your pool or your hot tub. It makes it pretty easy, yeah. Not only for the homeowner, we're finding a lot of service techs are taking the product as well, because they actually want to remote monitor their customers' pools and to make sure their chemicals are in perfect balance as well.
What happens if they're not in balance?
Well, you know the whole syndrome of a green pool? Well, that happens a lot. So people end up having too much of one thing or not enough of another, and it becomes a bit of a science project, and it starts looking a mess pretty quickly. Well, to start off with, Fin isn't designed to actually just resolve a green pool. You need to get your pool in a fairly good condition to begin with, get a tech in to make sure your pump's working properly, the filter's working, and that everything is in good condition, including the water. Then you put Fin in then, because then Fin is going to maintain that water condition moving forward. And what it does is it's constantly monitoring the water chemistry, and it's looking at the chemical changes, especially in a hot tub. If you just get in the hot tub, you're going to put a lot of sweat in there, and you're going to need to sanitize for that. And so with Fin, it's analyzing the usage of the water and the chemical changes, and then making recommendations to actually put in new chemicals and bringing it back to balance again. Fin works in two ways. We either work with a retail model or we work with a direct to the consumer. From a retail model, you can buy Fin as a hardware-only product in store, and it works with all your chemicals you buy from your retailer. That helps the retailer sell more chemicals. It helps you actually have that relationship with those brands you already trust for chemicals to work together. If, however, you're one of these people that likes to buy things on Amazon and you like to subscribe, then Fin is great for that too, because we can actually sell you Fin. It comes free of charge if you then sign up to a chemical subscription, which will deliver those pods to you on a yearly basis.
So that was just a very quick run through some of the many, many new ideas that are being transformed from ideas into reality at the playground. Many of them will be great news for poorer developing countries like India. Perhaps we also need an equivalent of the playground in India. It's worth a thought. So that's it for this three-part series on The Future Is Now from the playground in Silicon Valley. Once again, you can see all 3 episodes of The Playground on ndtv.com. Just log in and search for The Playground. So we leave you now with a montage of some of the amazing ideas and concepts at this wonderful new world that will soon be part of our daily lives all across the world. Thank you very much for watching.
The 4 of us have been through more than a dozen startups over the last 30 years, and we've really had a great experience. And we want to make sure that the next generation kind of has all the tools and the capabilities to not make the same mistakes we've made when we were young, and that we can participate in their journeys.
Some of these have been in movies, in Transformers, in The Accountant.
In movies?
Yeah. They don't encourage good behavior.
So what Playground brings to the table is human capital and financial capital under one roof. This is the breakthrough innovation model today.
3D metal printing technologies to be able to print the entire rocket.
So this is an electric conversion of a go-kart. It's incredibly powerful, which is probably a mistake. So we're printing something like this out of titanium. It has a very a bounce. Good catch.
This 3-pound mass between our ears, is a mystery.
We could have buildings that literally sublime out of thin air. Trees do it. Trees are made of air, right? There's no reason why we can't grow buildings the way nature grows trees.
Did you see Iron Man?
Oh,
it's
the
a Nest
Nest.
thermostat.
Nest, yeah.
And so I don't know if you ever watched Iron Man, but it used to be that, when it got cold in here, the Nest thermostat would turn on and his eyes would light up red.